Hello student, today we are going to learn our second topic, that is thermodynamics. Now before going to the first point, that is the first law of thermodynamics, we should know the basic terms which are used in the thermodynamics. You have learned all these two terms in the 12th science. For example, the system, which is a part of the universe, which is under thermodynamic consideration. The surrounding, the part other than system, is called as the surrounding. Then the different types of system, like that of open system, closed system, isolated system, homogeneous system and heterogeneous system. Open system, to which we can exchange matter and energy with the surrounding. Closed system, which can exchange only energy, not the matter, with the surrounding. Isolated system is a system in which cannot exchange matter as well as energy with the surrounding. Homogeneous system, which is uniform throughout, having only one phase, is called as a homogeneous system. Heterogeneous system, it is a system which is having more than one phase, is called as a heterogeneous system. Then the thermodynamic properties. There are two types of thermodynamic properties, that is extensive properties and intensive properties. Extensive property means which property is depends upon the quantity of matter, like that of the mass. Mass depends upon the quantity of matter. Whereas intensive property, this is the thermodynamic property which is independent upon the quantity of matter. For example, the density, temperature, these are the properties which are not depends upon the quantity of matter. For example, if you measure the boiling point of water, if you have 1 liter of water, then its boiling point is 100. If you have 10 liter of water, then also its boiling point is 100. That means this temperature is not depends upon the quantity of matter, that's why it is a intensive property. Now then, state of the system. When all variables of the system are the constant, then it is said that system is in a state. Then state function property, the property which depends upon initial state and final state and not depend upon the path used to change the state, is called as a state function property. Now then, there are different processes, like that of isothermal process. Isothermal means temperature remains the constant, delta T is equal to 0. When temperature is the constant, then internal energy is 0, that is change in internal energy is 0, delta U is equal to 0. At that time, if temperature is constant, then enthalpy or heat of the system changes. The system is not thermally isolated. We call the system is not thermally isolated. That means heat can be added or heat can be removed from that system. Then another process is the adiabatic process. Adiabatic process means the process which is carried out at constant enthalpy. That is, heat of the system remains the constant. When heat of the system remains constant, then temperature never remains the constant. Therefore, delta T is not equal to 0. If the process is exothermic, then heat is evolved. That heat is not given out because we have to keep the heat of the system constant. Therefore, that heat remains in the system, and as a result temperature increases. That's why delta T is not equal to 0. If temperature changes, then internal energy is also changes. Therefore, delta E is also 0 in case of adiabatic process. And then it is said that system is thermally isolated. System is thermally isolated. Now then, third type of process is isobaric process. Isobaric process in which the pressure of the system remains the constant, delta P is the constant. Then isochoric process, the process in which volume of the system remains the constant, it is called as isochoric process. Cyclic process, the process which undergoes series of changes and returns to the initial state, is called as a cyclic process. Reversible process, the process which can be reversed at any stage by infinitesimal small change in the opposing force. Opposing force, if you change or increase the opposing force, system get reversed, then it is called as a reversible process, which is a slow process, which is a multi-step process, which is a theoretical process. Irreversible process is the process which cannot be reversed, which is a one-step process, which is a natural process, which is a single step process. It is a irreversible process. Now then, in 12th science you learn the thermodynamic property like that of the internal energy. It is denoted by capital U. Then enthalpy, it is denoted by capital H. H is equal to U plus PV. Then you learn the heat capacity, that is molar heat capacity, that is CV and Cp. Cv is the molar heat capacity at constant volume and Cp is the molar heat capacity at constant pressure. Then the relation between Cp and Cv, Cp minus Cv is equal to R. Then you learn in the 12th science, that is the Kirchhoff's equation and the Hess's law. Now these are the basic terms which require to study this thermodynamics. Now let us say the first point in our syllabus is a first law of thermodynamics. This first law of thermodynamics is also known as the law of conservation of energy. According to this law, there are different statements for the first law of thermodynamics. Let us see the first statement. The energy can neither created nor destroyed, though it can be converted from one form into the another form. That means we cannot create energy, or we cannot destroy the energy, but only we transfer energy in one form into the another form. We know that when you use the electricity, that electricity can be converted into the wind power by means of a fan, or if you use the heating coil, then that electrical energy get converted into the heat energy. That means there is only transfer of energy from one form into the another form. We cannot create the energy, we cannot destroy the energy. Now the second statement of first law of thermodynamics. When a quantity of one form of energy disappears, an equivalent quantity of another form of energy appears. That means when a certain quantity of energy is utilized, its equivalent quantity of another form of energy is generated. For example, if you see the heating coils, in the heater, the coils are having the 200 watts, 500 watts, 1000 watts, 2000 watts. That means that much amount of electricity is consumed, we will get its equivalent amount of the heat energy generated. Therefore, there is a quantitative relation between the amount of energy disappears and amount of energy which is get generated. Now there is a quantitative relation between one form of the energy and the another form of the energy. Now the third statement, the total energy of isolated system remains constant. Isolated means there is no exchange of energy and matter with the surrounding, and that's why the total energy of a isolated system remains the constant. Fourth statement, it is possible to any machine to do work without consuming the energy. It is possible to any machine to do work without consuming energy. It is not possible actually. It is not possible to any machine to do work without consuming the energy. Now it is corrected. It is impossible to any machine to do work without consuming the energy. That means to do work by a machine, it requires the energy. The fan will operate by using the electricity. The human body can work by using the food energy. That means to do work for any machine, it requires the energy. Only the difference is that one form of energy get converted into the another form of the energy. Meaning of the statement is the same. And the last statement is that the total energy of universe is always constant. The total energy of universe is always constant. If you consider universe as a system, then the total energy of universe is a constant. That means if universe is a system, it is an isolated system, there is no exchange of energy and matter with the surrounding, and therefore the total energy of universe is always constant. In this way, there are 5 different statements of first law of thermodynamics. First is the energy can neither be created nor destroyed, though it can be converted from one form to the another form. Second, when a quantity of one form of energy disappears, an equivalent quantity of another form of energy appears. Third, the total energy of isolated system remains constant. Fourth, it is impossible to any machine to do work without consuming the energy. And fifth, the total energy of universe is always constant. Now, these are the 5 different statements of first law of thermodynamics. Now, then mathematical form of first law of thermodynamics. Before going to study the mathematical form of first law of thermodynamics, one should know that the internal energy of system increases when energy in form of heat is added by heating. The internal energy of a system increases when energy in the form of heat is added by heating or by doing work on system. On the other hand, internal energy of system decreases when energy in the form of heat is removed by cooling the system or by doing work by the system on the surrounding. Work is done by the system on the surrounding, that is the expansion type of work, right. That means internal energy can be increased by heating, or internal energy can be decreased by cooling or removing the energy, right. Now, with this concept, let us say if we have a system at its initial state with internal energy U1, we have a system which is a initial state, its internal energy is U1. Suppose Q amount of energy in the form of heat is supplied to the system. We supply the Q amount of heat energy to the system. As we know that when heat is supplied to the system, the internal energy will be increased. This added heat energy would increase the internal energy. Suppose that W work is done on the system by the surrounding. Work is done on the system by the surrounding. That is the compression type of work. This also increases the internal energy. This amount of work increases the internal energy. Hence, the internal energy of the final state. Now, initial internal energy is U1. We increase the internal energy by means of adding Q amount of heat energy, and also we do the work on the system, that is work is done by surrounding on the system. It is a compression type of work done. Then also there is an increase in the internal energy, and now due to all this there is change in internal energy. That internal energy of the final state U2 will be given as U2 is equal to U1 plus Q plus W. Rearrange it. U2 minus U1 is equal to Q plus W. Now, final minus initial is a change in internal energy. It is given by means of delta U. Delta U is equal to Q plus W. This is the equation number 1. Now, the equation 1 is also written by means of a small change. Equation can be written as du. Instead of delta U, here is the du. Small change in Q is dQ. Small change in work done is dW. The equation becomes du is equal to dQ plus dW. This is the equation number 2. Now, this equation 1 and equation 2 are the mathematical form of first law of thermodynamics. Now, this is the mathematical form of first law of thermodynamics. Therefore, mathematically, the first law can be stated as du is equal to dQ plus dW. Right? Now, this is the mathematical form of the first law of thermodynamics. Now, let us see the next point. The sign conventions of Q, that is heat, U, that is internal energy, and W, it is the work done. The plus Q is equal to heat is absorbed by the system. That means whenever heat is absorbed by the system or heat is supplied to the system, then the Q is taken as a positive Q. Heat is given out by the system, that means heat is removed from the system. At that time, the Q is given a sign negative. Whenever there is an increase in internal energy, then change in internal energy delta U is positive. The sign is given is the positive. Whenever there is a decrease in internal energy, then delta U is given a sign negative. Now, whenever there is a work is done by system on surrounding, expansion is there, at that time the work done is given a negative sign. And when work is done on system by the surrounding, compression is there, work is done by surrounding on the system, compression is there, at that time work done is the positive. Now, these are the sign conventions for Q, U and W. Now, let us rememorize it. Plus Q is heat absorbed by the system, minus Q is the heat is given out by the system, plus delta U is increase in internal energy, minus delta U is decrease in internal energy, minus W is the work is done by system on the surrounding, expansion is there, minus W, plus W, work is done on system by surrounding, that is the compression. Now, this is about the sign conventions for the 3 different terms or the properties, that is Q, U and W, heat energy, internal energy and work done. Thank you.